Mr. Pelton. This is Professor Pelton. This is part 3 of chapter 7, section 2. So, picking up from the last section, we wondered why the sine of 60 and the cosine of 30, and conversely, the cosine of 60 and sine of 30 will end up being the same value. Well, if it's in a right triangle, whatever the one angle is, the other angle must be 90 minus that, because the total needs to be 180 after you subtract out the right angle, right? So, if I'm doing the sine of theta, right, that is the opposite over the hypotenuse. If I'm doing the cosine of this angle, that's the adjacent over the hypotenuse. And either way, it gives you A over C, doesn't it? Right, so either way, you get A over C. Okay, all right, so that basically gives you the cofunction identities, the fact that the sine of an angle is equal to 90 minus the, the angle for the cosine, so on and so forth for all of the 6 trig functions accordingly, right? So S goes with C, C goes with S, and we're okay. And that works for both radians and degrees, because keep in mind 360 degrees is a relative countable number and how you break it up, but the actual measure is in radians. So when you do it in your calculator, it's actually breaking it up into, it's actually converting it to radians to be able to do the math. All right, so the sine of 72, if I want the cofunction, that is the cosine of 90 degrees minus 72. So that's the cosine of 18 degrees. So if you plug it in your calculator, these two things would give you the same value. Okay. So this would be the secant of pi over 9. I'm sorry, pi over 2. What am I saying? Minus pi over 3. And you're asking yourself, well, why is that? Well, pi over 2 is 90 degrees, right? Because pi is 180 degrees if you look at the unit circle, right? So half that is obviously 90. So the secant, so I need common denominators, right? So that's 3 pi over 6 minus 2 pi over 6. So I get the secant of pi over 6, right? And that's in radians. Okay, so if tangent is x, then cotangent is 90 degrees minus x. Or you can put pi over 2 minus x. It won't really matter. It all depends what you want as far as the measure, radians or degrees. Remember, any formulas you do in physics or science class or math class, all the formulas, they use radians. All right, pause the video, try the student problem. Okay, so the cosine of 44 is the same as sine of 90 minus 44. So that gives you the sine of 46 degrees. Okay. And then the cotangent, cofunction is tangent. So that's 90 degrees minus pi over 12, right? So tangent, if I turn those to both the common denominators of 12, that's what? 6 pi over 12 minus pi over 12. So that gives you the tangent of 5 pi over 12, right? Here we go. Yes, okay. So if cosecant of 90 minus x, and then the secant would just plainly be x, right? Think of it this way. I'll put that as degrees, just so it's, actually wouldn't actually matter. Could be either 1 radians or degrees after you get rid of the 90, right? Because if I do 90 minus x, I'll get back to the cosecant essentially. Okay, so we've identified what the values of the trig functions are relative to the sides and the angles, right? So when you use these, you typically talk about angle of elevation and angle of depression. So whether you're using a sextant or a transit or just using your eyeballs, you're going to have an LOS, a line of sight, okay? So in this case, this is the line of sight, right? And in this case, this is the line of sight. Okay, and relative to the line of sight, you're going to have an angle of elevation and angle of depression. Okay, um, so this is the LOS on the bottom here. So you actually have two LOSs depending on how you're looking. Okay, all right. So you either measure it or don't measure. It could be your eyes or transit or sextant, depending what you're doing. All right, so let's make a relative diagram down here, or a pseudo diagram. and then we'll solve some problems. Okay, so you stand on top of a mountain. So let's see if I can draw a mountain here. No promises there. Okay, so I'm going to stand on the mountain. There we go. I'm going to stand on the mountain. Okay, there's my two arms. So there is my, right? Make a little bit extra dots there. There's my line of sight, right? So there's a plane in the air. So I'm going to look up, right? And then this is 30 degrees. And here is my plane, right? So that is my angle of elevation because it says the plane is 30 degrees in the air. That's the angle of elevation. So on the ground is a camp. So we'll just say right here, there's a camp, right? And my angle of depression is 15 degrees, right? All right, so let's see here. Angle of elevation. This is my angle. Let's remove the LOS here. Ah, that's not an eraser. This is my angle of depression, right? And this is my LOS. Okay, so that's the general setup of a problem. Let's try some actual problems now. So when you do trig, you're either solving for one of two things: a side length or an angle. One of the two. Maybe both, depending on what you're doing. But typically we're just doing one or the other. Okay, so I want to know how tall this building is. So I use some kind of tool. What did I use in this case? A transit to measure the building, and I got the measure of A, and I started 300 feet back, and it was 22 degrees when I measured it. Okay, well, that's tangent of 22 degrees because the measures that are given are opposite over adjacent, right? So this is opposite, and this is adjacent. So basically, if I multiply by 300 on both sides, 300 times the tangent of 22 degrees is equal to A. And I'm not going to get that value because A is not the answer. I want the height of the building, and the problem is the device that I'm using is going to be 5 feet off the ground. So the actual height is 300 times the tan of 22 degrees, okay, plus 5, okay? So the height is approximately 126.21 feet. And again, when you type these into the calculator, if you're plugging in degrees, make sure it's in degree mode. If you're plugging in radians, make sure it's in radian mode. Okay? All right, pause the video. Try the next student problem for yourself. All right, so you're going to climb up a pyramid, and we're going to try to figure out how tall that pyramid is based on some measures. All right, so I'll draw a pyramid. No promises on the quality here. I'm going to stand on that pyramid. I'm leaning a yes, right? See if I can make a straight line here. That wasn't very good. Let's fix these dots over here. Okay. All right, so that's my line of sight. Not very good line of sight, but a line of sight nonetheless. Okay, so I'm going to use a laser. I'm going to measure down. So that's my angle of depression to the ground over here. All right. And my angle of depression, according to this, is 52.6 degrees. And it's telling me this is 213 meters. Okay. Okay, here's the problem, though. The height of the pyramid is not that, right? So what we're going to do is we're going to figure out this distance here. We'll call that D. How's that sound, right? So when we do that, the problem is when I create this triangle, this angle right here is also 52.6 degrees because they're alternate interior angles from geometry, right? So what I'm going to use is the sine of 52.6 degrees, right, equals the opposite over the hypotenuse, right? Because if you think about the relative triangle, right, I really have a right angle here, and the opposite is D, right, which is over here, right, and the hypotenuse is 213. Okay, so if I solve for D by multiplying by 213, I get 213 times the sine of 52.6 degrees. So that's D, which is not the actual height of the pyramid, right? So the height of the pyramid is minus my height, which is I'm standing on the top, which is the 1.5 meters. Okay, so the actual pyramid H is 213 times the sine of 52.6 degrees minus 1.5. Okay, and again, notice in both problems I did not do an estimate for this trig function prior. I took it holistically because you don't want to do estimates upon estimates. Okay, don't do that. All right, wait till the end to get the final estimate. So the height is actually approximately 167.71 meters. Okay. All right, let's try the last page. So in these two problems, we found the distance. We can also find the angle. And the way we find the angle is using inverse trigonometry, which is what we'll parlay into in the next lesson in chapter 8. So if we have this building here and we want to know the angle, um, and we have these two lengths, the building is 21 meters and you're saying 25 meters away. So using those two, I don't have the hypotenuse, so I'm going to use tangent. So the tangent of the angle is the opposite over the adjacent. And these are both meters, which in fact will cancel because meters over meters cancel. So then we want the angle, so we have to get rid of the tangent function. So I'm going to use the inverse tangent function on the tangent. Okay, make it better now. So the little -1, just like in other inverses in the past, just means inverse. So they use them with theta, the angle equals the inverse tangent of 21 over 25. Okay, so theta is approximately some angle, right? One thing to keep in mind, depending on what calculator you have, arctan and tan inverse with the -1 mean the same thing. Arctan is typically the correct way to say it, which is the inverse of the tangent, but calculator buttons are small, so they tend to put the -1, which is the modern notation for inverse, on the button instead, just because they can't fit the entire word arctan or arctangent on the button. Okay, so keep in mind when you do this, do you want the angle in radians or do you want the angle in degrees? So when you use your calculator, again, make sure you know what mode it's in. So if I do tangent inverse, right, and I do 21 divided by 25, if I get that answer, this says degrees, that's the degree answer. Okay, so if I copy paste and I change this to radians, then this is in radians, right? And you're like, well, there's no pi there. Well, it doesn't have to be in pi, right? Pi is 3.14, whatever, keeps going forever. If you convert to decimal form, it's just irrational, goes on forever. Okay, so depending on what you want, you have to set the calculator accordingly. So you have 40.03 is close enough here for the missing angle. All right, so pause the video and try the student problem for yourself. Okay, so we want to figure out the angle. All right, so again, I'm going to use tangent in this case. Like, it's not always tangent. You can use any trig function you want, but this one we don't need the hypotenuse. We don't need the hypotenuse, so I'm going to. You also use cotangent also. So 75 feet is the opposite over the adjacent, which is 43 feet. And what you notice is the feet cancel. So then we'll use the inverse tangent to both sides. So 75 over 43. So the angle is the tangent inverse of 75 over 43. Okay, so the angle is approximately, if you put in your calculator, 60.17 degrees. Okay, so if you plug an angle into a trig function, you'll get the ratio of the sides. If you plug a ratio of the sides into an inverse trig function, you will get the angle, right? Because in trig, you're either looking for one or two things. You're looking for side lengths or you're looking for angles. All of this stuff is in terms of right triangles, right? All right, that's the end of part 3.